Good morning. Hope you're all able to see and hear me. Guys, I'm audible, right? Okay, that's great. Okay, we'll just wait for another minute or so that our other friends also join, and then we'll start the session. I have to speak, no, to be audible. I didn't speak anything. Now I think you can hear me. Good morning, Sri Ranga. Good morning, Vinay. Okay, now you can hear, right? Now you can hear me, right? Yeah, okay. So today we will take up TS EAMCET 2019 May 4th afternoon slot maths. Okay, so in continuation with our previous discussion, which was our JEE paper, today we are doing one of the EAMCET paper. Okay, today we are doing one of the EAMCET papers. Okay, so let's start off. So now first thing, what should we do, guys? First thing, tell me, how do we do? What did we do in JEE Mains? Firstly, tell me, what do we do in JEE Mains? What did we do? Most of you attended that session. Can you tell me what did we do there? How do we start the paper first? How do we start the paper? Rounds as usual, yes. So you have to solve it in rounds, I told you. Round 1, round 2, round 3. Yeah. But this is an EAMCET paper, right? So you have to adapt a little because this is speed-based paper. JEE, we had a lot of time. JEE, you just have 75 questions to solve, guys. Total, on the whole. Whereas in EAMCET, only in maths you have 80 questions, right? Only in maths you have 80 questions. Right? So, EAMCET only maths is 80, again physics 40, chemistry 40. Time is same. So, we can't mark, then come back. Mark and then come back, right? So, here you have to be a little quick. So, for your benefit, what I'm doing is, I'm solving 40 questions today and probably 40 questions tomorrow, right? We'll do 40-40. So that the session is also not heavy for you and we can do it pretty easily, right? So we'll do 40 today, we'll do 40 tomorrow, right? So in that way, you won't get bogged down with the paper because even I can't expect you to stay online for like 1.5 hours looking at the screen and all. So I mean 2-3 hours looking at the screen and all. So that is why I wanted to solve 40 today, 40 tomorrow, right? So we will still do rounds. So what I do is usually, even I do it in the same way, even the EAMCET paper, I split the paper into 2 rounds, first 40, next 40, right? And what here we do is, here we do it very quickly. Here you see first question. So here we go question by question. I am seeing the first question. What is the first question? Domain of the function, right? What do you think it is? Is it a round 1 or a round 2? Is it round 1, round 2 or round 3? Guys, tell me. Domain of a function. Is it round 1, round 2 or round 3? Can you tell me please? Guys? Tell me guys. Which round is this? Which round? Anyone? Tejas says round 1. Indranil says round 1. Bilal also says round 1. So we know it's a round 1 question. So what do? In JEE, we marked all the round 1 questions and then we came back. But here what we are doing is, if we identify it's a round 1, we are solving quickly. Okay? And we are keeping a 2-minute timer here. Only difference is here we are keeping a 2-minute timer. Even if you feel it's a round 1, Larry says round 2, okay. If you don't know domain concept, it's round 2. But I would say it is a round 1 question, guys. So what we do is, since it is a round 1 question, I will solve it immediately, right? Can you tell me the hint for this, everyone? Can you tell me how to solve a domain question? You have to keep that table in mind, right? You remember that table which we had in mind? Everyone? You remember that table which we had in mind, right? What was that table, guys? What was that table? If you have a square root and a numerator and a denominator term, right? Yes, if you have numerator and denominator term should always be greater than 0. Is that correct, guys? Denominator term should always be greater than 0. So what does it mean? Step x whole square minus step x minus 2, that should always be greater than 0. Correct? Can I write this? Yes, square root also cannot be negative, right? It cannot be 0 also. Why? Because if it is 0, it becomes infinity. So can I write this, guys? Everybody clear with this step? Everybody clear with this step? Yeah. So how do we proceed further? Step x square, I can write minus 2 step x plus step x minus 2. That should be greater than 0. Correct, guys? Again, I can do this. So you can factorize this, right? I can take step x common, step x minus 2 plus 1 common, step x minus 2. That should be greater than 0. Basically, what are we getting, guys? Step x plus 1 into step x minus 2. That should be greater than 0, guys. Yeah, that should be greater than 0. Now tell me, what next can I do here? So I got my inequation with me ready. How can I solve this, guys? Can you tell me how to solve this? Anyone? Tell me how to solve this. There are 2 methods of solving, guys. There are 2 methods of solving. There are 2 methods of solving. What are those 2 methods, please? What are the 2 methods? One, I can do wavy curve method, or other, I can just verify options, right? I can either use a wavy curve method or I can verify options. Correct? Very good. Aditya, Sriranga says options verification. Indranil says wavy curve. Tejas says wavy curve. Aditya says step x greater than 2. For this question, actually verifying options is easy, right? Why? Because glaring here, this is step x, right? Minus 2. This should be greater than 0 overall, right? Now look at this. This is step x, right? What is step of 2.99999? That is still 2, right? It's the basic property of step function. So if you take any 2 point something also, this whole part becomes 0. You can't get 0 here, right? It is not equal to 0. So what all options I can eliminate, guys? See, this option has 2, this option has 2, this option has 2 point something. So first, second, third, all of them are eliminated. Fourth is your final answer. Got it? Yes. Everyone understood, right? Everyone got it, please? Got it? So fourth option is our final answer, because step X cannot be 2 point something, 2 point something, right? So it's easy. So it's fourth option. Now tell me second question, which round? Agreed with this round 2, because there are two functions, f of x and g of x. Two functions they are asking us 1, 1 or 2. So we have to check for two functions. So basically I can't spend time, it will take a lot of time. So I will try to solve it later. That's clear, right? So this is round 2. That's why I call this as round 2. So round 2 I will skip. The trick which I will use for EAMCET is, round 1 I'll keep solving, round 2 I'll keep skipping, I'll come back to round 2. So what I'll do is I'll mark for review basically. Now look at the third question. Can anyone tell me which round it is? Third question, which round, guys? Round 1. Round 1, because this looks like a mathematical induction sum, right? This looks like a mathematical induction sum, correct? Now what did he say? N belongs to the set of natural numbers. What does it mean? I can take n value as 1, 2, 3, 4, 5 and so on. Correct? Yes. So I can take n as 1, 2, 3, 4, 5, 6, so on. This is like a series, guys. It looks like a complicated series, but all said and done, it is a series. Okay, it is a series. So what can I do here? I can give n value as 1. If you give n value as 1, what is happening? This is becoming 0, this is becoming 1. What does this mean basically? This means up to, right? This means it is up to 1. That means what? If I am substituting, this is 1. This will be 1 minus 1, 0. So we are getting up to 1. That means what? Only first term I have to take. Correct? So if I take 1 here, I have to substitute 1 also in the RHS. So what is this? This is also 1. 1 plus 1 is 2. 1 plus 2 is nothing but 3. So 6 alpha is 1. So alpha is 1 by 6. Is that clear? Yes, most of you have got it right. Yeah, I think there will be a little bit of lag because we are going on YouTube live. So little lag will be there. So don't worry about it. If you have any doubts, I'll go back to the question. There'll be, I think, 5-6 seconds of lag. So don't worry about it. So it's easy, right? So alpha is 1 by 6. See, Indranil, it's a series. It's a repeating series. It's n, 2 times n minus 1, up to so on they said, n minus 1 into 2 plus n into 1, right? So if you give n value 1, so we have to check the last terms, right? This is the up to term. So what will happen here? 1 minus 1, this is 0. This is 1 into 1. So you should get 0 plus 1 or 1 plus 0. We have to stop there. Wherever we get 1 plus 0 or 0 plus 1, we have to stop there. So LHS, what do we do here? We are, since this I am substituting 1, so I am checking now. First term, if you substitute, you are getting 1. Second term, if you are substituting, what are you getting? 2 into 1 minus 1 is 0. So same thing we are getting, right? In the up to series, the last two terms is 0 plus 1. So the first two terms will be 1 plus 0, which is what is the same. The same thing you should get if you are substituting. So LHS we are getting it as 1 plus 0 or 1. RHS we are getting it as 1 into 2 into 3. 1 into 2 into 3 is 6. So alpha is 1 by 6. Now tell me guys, next question. Can you tell me the hint of this guys? This is, tell me, round 1 or round 2? Round 1 or round 2? This is round 1. If you know determinants well, you will get the answer pretty easily actually. If you know the determinants well. Correct? If you know determinants well, you will get the answer easily. Right? Few things I told you in determinants, right? If you have a lower triangular or an upper triangular matrix as 0, right? If you take this part as 0, 0, your determinant will be sum of the product of the diagonals, right? Determinant of a lower triangular or an upper triangular will always be the product of principal diagonal elements. The product of principal diagonal elements. Alright, so how do I make this 0? What I will do is I will perform some row operations. Row 1 such that row 1 minus row 3. Row 2 such that row 2 minus row 3 I will do. That's it. If you do that, you will get a simple thing. So this is 1 minus 1, 0. This is 1 minus minus sin x is minus sin x. What about this? 1 minus 1 is 0 again. Second row will remain same. 1 plus sin x, 1. Okay, second row also I am changing, sorry. Second row also I am trying to change here. Okay, got it. So second row, how will I get guys? 1 minus cos x is minus cos x. 1 plus sin x minus 1 is nothing but sin x. Right? And what is this? 1 minus 1 is nothing but 0 is what we are getting. And what else is there here? So this is 1 plus cos x as it is. This is 1. This is 1. Now still we need this element also as 0, right? So how do I get this element as 0? I will do R1 such that R1 plus R2. So what am I doing? 0 minus cos x is minus cos x. Minus sin x plus cos x is 0. 0. This is minus cos x. This is sin x. This is 0. 1 plus cos x. 1, 1. Now what will be the determinant guys? Determinant will just be the product of the diagonal elements. So this I can take it as minus sin x cos x. So this is what we are getting actually. So my function is minus sin x cos x. Now your range is given, right? Domain, can you verify options? Yeah, you can take columns. You can do it in any way. I'm comfortable doing rows, so I just did this. Can you verify options? Can you just substitute each option and check if you're getting this as your range? Simple, right? Yes? Yeah, you can take columns, no issues. Many are saying take columns. Yeah, you can take columns. Got it? Everybody? Yeah, okay. Since we are doing R1 minus R3, this will be some... yeah, you are right. Anyways, you got the approach, right? 1 minus of minus cos x, so this will be minus cos x. So let me rewrite it. You know the method now. So I think I have subtracted with row 2. That's why you got that extra step. That is the mistake I made. So what you can do is actually 1 minus cos x is minus cos x I can write. 1 minus 1 I can write 0. 1 minus 1 0. Yeah, I think now you will get it directly. So 1 minus of minus, this is minus cos x. 1 plus sin x minus 1 is sin x. 1 minus 1 is 0 again. So 1 plus cos x, 1, 1. So same thing you are getting again, right? Same problem, same thing we are getting. So, but we will get it in one step if you just follow this. I've done it with R2, though I've written it as R3. So same thing. So if you can just verify options and check whichever option you are getting this. So second also done. Now tell me this guys, rank. How do you do rank, please? Rank, hint, anyone? Determinant is one method, Tejas, but I don't recommend that. I told you rank when we were discussing yesterday. I had premiered that video on YouTube as well, so that you refer that complex numbers and matrices doubts. In that video, I had discussed, okay, I had discussed that rank, if you want to find out rank, you have to perform row operations, you have to perform column operations, and then you have to count the number of non-zero rows. So this is like row 1, row 2, row 3, row 4, right? So what I'll try to do is I'll try to make elements as zeros. I will try to make each element as 0. So I will take this as base row. So how will you make a row 2 as 0, first element in row 2 as 0? R2 such that 3R2 minus 2R1 I can write. So this element will become 0. If I want to make R3, I will do it as R3 3R3 minus 8R1 I will do. And R4 if I do, I'll get it as 3R4 plus 7R1, right? If you do this, these elements will become 0, you will get something. So you keep doing row operations and column operations and then find out the answer. So I'll give it as a DIY. This is actually a round one only for me, but if you feel, some of you might feel this is lengthy, so you can do it as round 2. So I've given the hint, you know how to do row operations. So I want you to do it. I think you will get the answer as 2. Two rows will become 0 for you. I think the last 2 rows will become zeros. No need of taking 3 by 3. Again, I'm telling you, Sukirt, Jayant and all, determinant method, don't do it. This is the easier way, guys. Little bit of calculations, but here it will be sure shot. You can do augmented matrix, taking 3 by 3 determinant, that also you can do, your wish. But I would recommend this. Number of non-zero rows. Making zeros is easy. Okay. So you will do it, right? I hope all of you will do it. How is plus 7, ma? 3, no, this is 3. This is minus 7. So this should be 21, 21, right? So that is why we are doing 3R4 plus 7R1. Okay, this is minus, it should be, both should be zeros actually. I want to make this 0. So what is this? This is minus 7. This is plus 3. So I have to multiply 3 here, I have to multiply 7 here, and then if I add, it will get cancelled, right? Got it, Lyrie? Now tell me, this is again easy peasy, non-trivial solution, round 1 question. Tell me, what should be the hint for this? RHS terms are zeros. Can you tell me please, how do we solve this? How do we solve this? Come on guys, tell me. Det should be 0. Very good, Indranil. Det 0. So what will I get? 4 sin theta minus 3, 1. 1 minus 6 cos 2 theta, 1. And 3 minus 12, 4. That should be 0. And then verify options. Solve. Verify options. Easy. Easy peasy, guys. This sum nobody should miss actually. This is unmissable sum. All of you should be able to do this because it's very easy. Getting right, I think you will get something like sin inverse pi by 6 or whatever. You just check. Now tell me guys, look at this. Tell me, which round should I solve? This looks like a complex numbers and a square root is given to you, right? So if you don't know square root formula, it becomes round 2 or round 3. For me, this is a little tricky, right? Because they are first asking you to convert into polar form. They are also asking you to check the quadrant, right? So there are 2, 3 multiple concepts. So I keep a thumb rule in mind. If I feel more than 1 or 2 concepts are there, I will solve it in round 2 or round 3. I won't waste my time. Yep, so all of you are saying round 2, so we'll move on. Tell me this, guys. This looks a little simple, right? This looks a little simple. Only one inequality gave. They asked area. So let's try this. This I will keep it as round 1. Again, I'm telling you guys, one word of caution here. You might feel it is round 1. You might feel it is round 1, okay? But you might not be getting the idea. Still, you should not waste time. I told you, right, that 2-minute timer should come to your mind, right? Anything more than 1 round, you shouldn't solve, right? Anything more than 2 minutes, you shouldn't solve. So 2 minus, how do I write z? I'll write it as x plus iy, minus of 1 plus I. This should be less than 3. So 2 less than, how do you write mod now? This I can write it as under root of x minus 1 whole square plus y minus 1 whole square. That should be less than 3. So you can square on both sides. Square and root will get cancelled. 4 less than x minus 1 whole square plus y minus 1 whole square less than 9. Now can you tell me, guys, what is this equation looking like, guys? Can you tell me how this equation is looking like? Which equation is looking like? Which equation is this looking like? Which is this type of curve? This is a circle, right? This is a circle, as rightly pointed out by most of you. It is a circle. So what is the area of a circle? So basically, this circle is lying between. So if this is circle, this becomes R1, this becomes R2, right? So this is basically lying between R1 and R2. So what will be the area of this region? This will be 4 pi. This area will be what? 9 pi. What is the area? Pi r square, right? Here we are squaring the radius here. So this will be 4 pi, 9 pi. You want the area between them. How will you get the area between them? 9 pi minus 4 pi. Right? You want the area between these two circles. So it's 9 pi minus 4 pi. It's nothing but 5 pi. Sukit rightly pointed out even before solving that it is 5 pi, which is the answer. Simple sum, round 1 sum. So again, you are seeing, guys, complex numbers, they are giving everything together, right? This one, guys. Can you tell me how to solve this? Which round? Next question. Kind of round 2, I will say, because some calculations are involved. Some of you might find it as round 1 as well. You need to get that idea. P is a complex number whose modulus is 1. So that means what? If you take mod on both sides, it will be 1. And I can write mod of 1 plus iz whole power 4 by mod of 1 minus iz whole power 4 is 1. Or 1 plus iz whole power 4 equals to 1 minus iz whole power 4, I can write. Z you substitute as x plus iy, you will get a quadratic. Depending on that, you check the options. You need to check and cross verify. So approximately this question will take 4 to 5 minutes to solve. So that is why I kept it as round 2 actually. Yeah, rationalizing is one way, but why rationalize? Because he said modulus as 1. Basically, you have to take modulus concept. That is what they want you to do actually. Okay. Now tell me this, guys. What about this sum? What about this sum? This is actually very tricky, and I wanted all of you to leave this sum. If you are attempting this paper, even I told my other students the same thing. This question you have to leave, round 3 question, because look at this, guys. This is de Moivre's theorem. What we have? De Moivre's theorem. But again, it is given in terms of sine and cos, so you have to convert in terms of cos and sine. And you look at the summation, guys, r equals to 1 to 16. So probably you have to use geometric progression, correct? And probably you have to use few more calculations. Very lengthy sum. Instead of this, you can look for few easy peasy questions, right? So that is what I want you to do actually. So that's why this question you should have left. Euler form you can do, right? So I would say do this at the end. That is what I feel. If you know the concept, you want to try it, but for me it's time taking. So I will do it in round 3. Yes, looks very easy. As Sanjana said, sir, it is round 1. It looks like a round 1, but it's not actually. You have to figure out that 3 concepts are there. You are seeing summation up to 16. So that is why I'm saying automatically I parked it to round 3. Now tell me this, guys. The maximum value cannot exceed 20. Then what is the minimum value of A? Okay. So this for me is round 1. If you personally ask me, calculus is something, even in round 3 questions, I find it as round 1 only, right? So, but I am telling you, I am giving you a very rational view, right? Chapters like calculus, chapters like probability, permutations, for me, every question is round 1. But for you, it is not, right? So, I am giving you, so this is a round 1, this is actually a round 1 question. So, can you tell me which topic it is this from? Can you tell me which topic is this from? Inequalities, some are saying it is inequalities. I am not using inequalities. I want to use calculus here, right? I want to use calculus. What I will do is f of x, I will keep it like 2x minus 7 minus x square. Maximum value cannot exceed. So how do I find out maximum? First step I have to do is I have to differentiate. So what will I get? Derivative of 2x is 2 minus 2ax. Correct? This part will be 0, differentiation. So f dash x is 0, that will give me my, so 2ax equals to 2, x is equal to what? 1 by a basically I am getting. Now look at this, guys, the maximum value cannot exceed, only 1 point I am having. So I will try to find out the maximum value here. So how will I find out the maximum? I just have to substitute this here. 2 times 1 by a minus 7 minus a times 1 by a whole square. So this cannot exceed. Cannot exceed means what? Less than or equal to 20 you should have. Clear, right, guys? Now what can you do? The minimum value of a, which is satisfying this equation. Now look at this. If you keep denominator terms, if you keep 1 by 13 and all, it won't satisfy. So either it should be 27 or 13. So just check that. I think you should get the answer pretty easily. No, I think it's reverse. I've told the reverse actually. If you do 1 by 13, 1 by 27, you won't get it. If you do 27 and 13, you won't get it. So you have to check for these two options, guys. 1 by 13 and 1 by 27, check. One of them will satisfy. That will be your answer. So this is just verification from options. Sukit, you only tell me how to you check whether we can use calculus or not. This one, right? Minimum, maximum. Any minimum, maxima, I'll use calculus. Any minimum, maxima. Because minimum, maxima, simple steps, right? In calculus, find extreme value you can do. Right? You can do find extreme value. Then you can just substitute that value back. 2 steps only, right? So that is why any minimum, maximum, I will just solve. Understanding, everybody? Easy question, round 1 question. Now look at this, guys. Tell me this question, please. Exactly. Sriranga says wherever we are finding physics, maths, maximum, minimum, velocity, acceleration, everything you have to use calculus. Tell me, guys, this question. This question, very easy to identify whether it is round 1 or round 2. Tell me, this one. Round 2, right? Because look at it, multiple statements, complicated question. Though its concepts are simple here, it will take time. Time taking some. So I will do it in round 2, not round 1. See, I am telling this to you slowly, right? I am telling this to you in a slow and systematic way. In your exam, your mind should function pretty fast. Hope you're understanding, right? Now this one, guys, this one actually is somewhat little interesting. This one, this is a round 2 question for sure, or for few of you it is round 3 as well. I'll tell you why, because you need to get that idea. Power 4, it's rarely asked actually. This has popped up this year actually. Before till last year, it was not asked, right? So you can actually do it in 2 ways, okay? You can actually do it in 2 ways, okay? What I would recommend is, I would ask you to do it by approximations, okay? I would, the product of real roots, okay, he said product of real roots, so I can't even use approximations. I thought they're asking the root. So product of real roots, so you need to find the roots. How do you find the roots, guys? Can you tell me? Anybody hint for this? Very good, Larry. So basically what we need to do is, we need to convert into something common. So I can write it as x plus 2 minus 1. And this I will write it as x plus 2 plus 1. Why am I writing it as minus 1 plus 1? You know that formula, right? So x plus 2 I can write it as t. So t minus 1 whole power 4 plus t plus 1 whole power 4 I can write. So actually you know there is a standard formula actually, which is x minus 1 whole power 4 plus x plus 1 whole power 4. That part I think you will get something here. I think that part you will get something like 8 I think. I think you should get it as something like, so this is given as 8. So this part I think you will get it as 2 times x power 4 plus 6y square minus 3. Something of this sort I think you should be getting. So 2 times x power 4 plus 6y square plus 1 I think. Yeah, it should be plus 1. This is what you need to get. So you need to know this formula as well. Or if you don't know, you have to solve it in the rough. So this I have to substitute here. Correct? So I'll get 2 times t power 4 plus 6t square plus 1 equal to 8. 2 goes 4 times. Now you take it to the other side. Now solve it like a quadratic. Again solve it like a quadratic. So double quadratic you need to do. This is one red flag for me. Right? This is one red flag. This is one red flag, knowing this. So 2 red flags I have. That is why I said it is round 2 or round 3. Again, this is also red flag. Some of you might not get that idea that you have to put x plus 2 equal to t, right? So guys, competitive exam, what question you are choosing and solve, you have to get it. You have to do it in that way. Binomial, no man, it will become very complicated. No other method. Only this is the better method to solve. Again, even if you do it lengthy method, see, some questions are not meant to be in the exam. You have to leave it. Don't get attached to those questions, right? I always tell this is a thumb rule, right? These are just questions. They are not your boyfriends or girlfriends, right? To get attached. Yeah, okay. So don't get attached to questions. You might like the chapter. Don't get attached, right? Leave it. If you find it complicated, leave it. The cutoff is not 159 out of 160, right? Now tell me this. So if you waste time on this question, you won't be able to solve a simple question like this, guys. This is for me simple round 1. Right? This is a simple round 1 question, right? Yes, for me this is a simple round 1 question. Because mod x minus 3, I can write 2 cases. Either I can write it as plus of x minus 3, or I can write it as minus of x minus 3. So I'll get 2 cases, x square plus x minus 3 equal to 4, x square minus x minus 3 equal to 4. 2 cases, find the roots, quadratic, and then In that, only real numbers you have to take and sum all of them. Only real numbers you have to take and sum all of them. I think real numbers you will only get 2 numbers. Okay. I think you will only get 1 plus root 5 by 2, 1 minus root 5 by 2. You will get. So if you add these two after solving these, one I think you will get complex roots, so directly you can eliminate. The other, it will be 1 by 2 plus 1 by 2. I think you should get it as 1 as the answer. So you do it DIY from this. Very simple, round 1. Clear, right, guys? Everybody clear, right? Easy peasy. Sir, please come live daily. Okay, we'll see. I don't want to bore you every day, man. That's why I don't come live daily. I get bored of myself sometimes. You know, I get bored of myself. Okay, tell me this. This is again simple round 1, guys. Basics of P&C. Basics of P&C. This one. Basics of P&C. Now tell me which all are wrong. This is correct. NPM, number of 1, 1 functions. This is also correct. N distinct things, at least 1. At least 1 means what? NC1 plus NC2 up to NCN, right? So that will be what? Formula is 2 power n minus 1. This we already discussed. What about circular table, guys? Circular table, the formula is n minus 1 factorial, but they gave n minus 1 factorial by 2. Not possible. Now arrangement in K-bins. This is like solving, right? Number of positive solutions, non-negative solutions. If you refer my permutations and combinations, video, you will find this. So this is what? N minus 1 Ck minus 1, right? But here it is given as N Ck minus 1. Wrong. So what is this? Only first and third statements are correct. So options were like 1 and 3 are correct. 2 and 4 are false, whatever. Those are the things. Sriranga is asking again, he's going back to the previous question. How will it get 0? Gentlemen, this and this will get cancelled, right? You will get half and half. You should get 1 as the answer. So again, this you shouldn't miss, guys. Easy cake question. They have given it on the platter, this question. Now you see, if you waste time here in this question, you will lose confidence and you will miss out on 2 simple questions. Now tell me this, guys. This actually I'll call it round 0. It's not even round 1, it's round 0, guys. Yes, Sukit, they asked us to pick. So first option was first statement true, second statement false. So like that. Now look at this, round 0 question. Why round 0, guys? This is as easy as you can get. This is again, if you know this statement, right? If you know that this is wrong, you know the formula here, right? What is this? 3 identical balls, 7 bins, right? So how can I write this? How can I write this, guys? x1 plus x2 up to x7, that you need to give it in 3. So anything, any possibility is there? So I can write 7 plus 3 minus 1. See, 7 minus 1, right? 3 identical balls to be distributed in 7 bins. So this should be 3, 7. So this will give you your answer direct straight. 9C6, yes. 9C6 will give us the answer. Straight, easy peasy question. You won't get questions easier than this, guys. So that's why round 0 I would say. You should say which is distributed in what. Identical balls you want to distribute in this. So even forget this. All this you want to distribute in this, right? So this will be my K. N plus R minus 1, C R minus 1. So this will be R, this will be N, right? Yes. Now tell me this, guys. This is direct binomial theorem. Binomial theorem, guys. Indranil, it's not positive, it's not negative. You want, see, there are 7 bins, right? I want you to be conceptually clear, guys. So you can put 3 identical balls. So you can put 3 here, 0, 0, 0, 0, 0 here also as well, right? So that is why this question, it's non-negative solutions. That's why you have this. If it is positive, I would have taken 7 minus 1, 3, C 3 minus 1. Now look at this binomial theorem. Some are saying 1, some are saying 2, some are saying 3. Okay. So I'll give you a simple hint for this. If you know the hint, it is round 1. If you don't know the hint, if you solve it by actual method, it is either round 2 or round 3. Can you tell me what is the hint? Observe and tell. You're all smart by now. What should I do to do this? Oh, yx, guys. Why do you want to give x value? Can I give n value, guys? Can I give n value? Yeah. Can I give n value? Can I give, let us say, n value as, if you give 1. What is happening, guys? First option is 1. Second option is 3. Third option is 4 by 2, which is 2. Fourth option, 3 power 1, 2 by 2, which is 1. So you might get a tie here. So safe side, I will give n value 2. What is this? 1 plus x square whole square, right? This is like a plus b plus c whole square. So I can write 1 plus x square plus x power 4 plus 2x square plus 2x cube. Correct? Now tell me, guys, what will be a0? a0 1. a1 will be what? That is the x term. That will be 2. a2 will be what, guys? That will again be 1. X cube, a3, 2. a4, 1. Easy, right? Then you can just substitute this here in first, second and third, whatever they have asked, and you can match, right? Easy, guys. So I've just converted this into a mathematical induction question. I'm not using binomial theorem. I've just used given n equal to 1, n equal to 2, expanded, compared, you got the coefficient values, and I'm just giving in this. So it's round 1 if you know this hint. Wherever question option in terms of n, you just have to